Hello students, today I am going to give the introduction regarding the abrasive jet machining process. So the contents for this topic: introduction to NTM, that is non-traditional machining, abrasive jet machining. Regarding the abrasive jet machining, introduction will be given, introduction for the equipment will be given, process of material removal, process variables will be given. Regarding the process variables, we will be discussing regarding the carrier gas, type of abrasive work material, stand-up distance. Next, we will be discussing regarding the process characteristics, that is material removal rate, nozzle wear, accuracy and surface finish. Next, we will be discussing regarding the advantages, limitations, applications and so on. So coming back to the topic, we'll be discussing now what is this machining process. Machining is in broad term to describe the removal of a material from a workpiece. The machining categories are cutting, abrasive, non-traditional machining. In the cutting process category, it involves single point cutting or multi-point cutting tools, each within a clearly defined geometry. Then abrasive, small particles are removed from the workpiece such as grinding. Next, the main topic of the discussion is the non-traditional machining, where it is going to utilize the electrical, chemical and optical sources of energy. Next, here you are saying the material removal process is being divided into two: traditional machining and non-traditional machining. In the traditional machining, we have the classification cutting. Cutting is again being divided into this process: circular shapes like turning, boring, drilling. Next, various shapes: milling, shaping, planing, sawing, filing, broaching, gear forming. Next, the mechanical abrasion process is also included under the classification of traditional machining: bonded abrasives, grinding, hunning, coating, then loose abrasives, polishing and buffing. The non-traditional machining are USM, that is ultrasonic machining, abrasive jet machining, water jet machining, electrochemical machining, electro die machining, ECG, PBM and LBM, CHM. So next we will be discussing what is the difference between traditional machining and non-traditional machining. In traditional machining, this traditional machining is also called as a conventional machining. Even non-traditional machining is called as a non-conventional machining. What are the primary source of energy? You can differentiate these two machining process on the basis of the primary source of energy. The traditional primary source of energy is the mechanical. The non-traditional primary source of energy is the electrical, chemical, optical. The primary method of material removal in case of traditional is searing. Non-traditional doesn't use any searing, for example, abrasive jet cutting. What is this NTM? Because you are discussing regarding the AJM, so you will be talking on the topic of non-traditional machining. Traditional machining is mostly mostly based on the removal of the materials using tools that are harder than the materials themselves. New and novel materials are all sometimes impossible to machine using this traditional machining process, like drilling, cutting, turning operations. Traditional machining methods are often ineffective in machining hard materials like ceramics and composites, or machining under very tight tolerances as in micro machine components. The need to avoid surface damage that often accompanies the stresses created by the conventional machining, example in the aerospace and the electronics industries. They are even classified under the domain of non-traditional process. Next, why non-traditional machining? Some situations are being created under the traditional machining processes are very unsatisfactory and or uneconomical. Why? The workpiece material is too hard, strong or tough. Workpiece is too flexible to resist the cutting forces or too difficult to clamp. Part shape is very complex with internal or external profiles or small holes. Requirements for the surface finishes and tolerances are very high. Temperature rise or the residual stresses as undesirable or unacceptable. That's why we go for the NTM. Next. Advantages of NTM. Advantages of NTM, like you can see, complex shapes can be machined, machining in accessible areas, low tolerance can also be given at the rate of 0.01 millimeter, better surface integrity, that means no surface defects are being observed in the NTM which are being manufactured by this NTM. High level surface finish is also there, nano level machining is there. Miniaturization of the products like landline phone, mobile, old computers and laptop. High removal rate, that is MRR. High production rate while processing difficult to machine parts. Low cost of production. Precision and ultra precision machining operations. Requires material removal in the form of atoms or molecules. Disadvantages of NTM. What is the main disadvantage of NTM? It is having a very high initial or setup cost. High skilled labor is required. Lower material removal rate. More power required for machining. It is not economical for the bulk production. That's why we even sometimes don't prefer the NTM. What is this NTM, non-traditional machining process? That is also called as a non-conventional manufacturing process that removes excess material by various techniques involving mechanical, thermal, electrical or chemical energy or the combination of all these energies. This process even do not use any sharp cutting tools as it needs to be used by the traditional machining process. Like in the lathe machine tool, we prefer to do the machining operation by single cutting tool. Even in the case of drilling, you can observe there are multi-point cutting tool in the drill bit. So here in the case of NTM process, we never used to prefer any sharp cutting tool. The major characteristics of the non-conventional machining are the material removal may occur with the chip formation or even no chip formation may take place. AJM, that is abrasive jet machining, chips are of very microscopic size. ECM, electrochemical machining, the material removal occurs due to the electrochemical dissolution at the atomic level. Next. In case of NTM, there may not be a physical tool present, but the laser beam machining is carried out by the laser beam only. That means that if you are going to use the laser beam machining operations, you are going to focus on that workpiece by the laser action, by the beam action of that laser. Then by the force of the action of that beam on that particular surface of that workpiece, it will automatically do the machining operation. Electrochemical machining, use of the physical tool is required for the machining process. In NTM, the tool need not be harder than the workpiece material. The tool may not be harder than the workpiece material. In EDM, electro discharge machine, the copper is used as a tool material to be machined hardened steels. In case of NTM, different energy domains are used to provide machining operation. USM, AJM, WJM, mechanical energy is used to machine the material. In case of ECM, electrochemical dissolution constitutes the material removal. So here we go for the classification of the non-traditional machining. The non-traditional machining is being classified according to the source of energy used to generate the machining action. So there are near about 4: mechanical, thermal, electrochemical, chemical. What is this mechanical? Erosion of the work material by high velocity stream of abrasives or the fluids is called as the mechanical way of removal of the mechanical way of non-traditional machining. In case of thermal, the thermal energy is applied to a very small portion of the work surface, causing that the portions to be removed by the fusion or vaporization of the material. The thermal energy is generated by conversion of electrical energy only. Electrochemical mechanism is just reverse of the electroplating only. As if you all know the mechanism behind the electroplating, just a coating has to be done in case of electroplating. Just it is the reverse of the electrochemical is a reverse of electroplating. Chemical Most materials are susceptible to chemical attack by certain acids or agents. In chemical machining, chemicals selectively remove the material from portions of the workboard, while other portions of the surface are protected by the mask. This is called as the chemical way of non-traditional machining process. Here, this is the non-traditional machining. It has been divided into mechanical, thermal, electrochemical and chemical. Below the mechanical, there is USM, WSM, AJM, IJM. Similar in case of the thermal, there are EBM, ECM, LBM, IBM. In case of electrochemical and chemical, CHM, PCM, ECM. Here, but as per your syllabus, we are going to discuss regarding the AJM. In the next class, we will be discussing regarding the AJM. What is this AJM? What are the process characteristics of the AJM? So AJM nothing else, it's an abrasive jet machining operation in which the fundamental principle of abrasive jet machining, it involves the use of high velocity of stream of abrasive particles carried by high pressure gas or air onto the work surface through a nozzle. So in detail we will be discussing regarding the AJM in the next class. So thank you very much.